Hello again, chemistry. Mr. McKee here, and I want to go over the lab procedure for today's lab. So please follow along with me in the booklet, underline important points, and follow along with the steps, please. Okay, I want to begin by reminding you about evaporation, what it is, because that's the main phenomenon that we're exploring in today's lab. It's similar to boiling, except that it only happens at the surface, and because of that, a less temperature is required to break the IMAFs. In both cases, we are overcoming IMAFs, which are these intermolecular forces between molecules, either hydrogen bonding or dispersion forces or dipole-dipole forces, okay? To go a little bit deeper into that, since we're focused on evaporation, evaporation equals cooling because as the liquid absorbs heat in order to get it to overcome these IMAFs, when those molecules escape into the air, they are taking heat with them. So think of these red arrows here as representing heat. And this is the basis for why humans sweat, because the liquid on our skin, as it evaporates off of our bodies, takes heat with it, and that keeps our body temperature at a consistent 98 degrees approximately. Okay, the other thing here is stronger IMAFs must absorb more heat to evaporate. Okay, so remember that for today's lab. And weaker IMAFs evaporate and therefore cool more quickly. So you might think that the best sweat would be a sweat that had really weak IMAFs, but that may not necessarily be the case. Kind of keep that question in mind as we go through today's lab. So we're going to be experimenting with 6 different liquids: acetone, also known as fingernail polish remover, hexane, heptane, ethanol, and butanol. Hopefully you've made some predictions about which of these molecules are going to have stronger or weaker IMAFs based on their structure here. Remember, we're looking at things like polarity, whether the molecule is polar or nonpolar, and we're also looking at size. Those are the main variables for this lab today as you make your predictions. Okay, let's begin with step 1, which talks about the equipment we're going to need, and then I'll go over the setup with you. You're going to get a gray box called a LabQuest Stream box, and it's basically an interface between your temperature probes and your Chromebook. So you'll need to plug this thing into an outlet around the perimeter of the room, and then you're also going to plug it into your Chromebook, the USB adapter there. And then you're going to have 2 temperature probes plugged into your LabQuest also. And we're using 2 probes today so that we can measure the temperature of 2 liquids at a time. The only reason we're doing that is to speed up the lab a little bit so that we can finish it in 1 period. So that is your basic setup there. Let's move on to step 2. So the main thing with step 2 is we need to figure out which probe goes with which temperature on your graph. When you plug your probes in, it should bring up this software, the Vernier Graphical Analysis software. So if you don't see it there, you may need to search for that. And you'll notice that there is a color for each temperature off to the left. Each time you run a trial, those colors are going to change. So we can't depend on the colors to identify the probe that we are using. So we have to identify what temperature 1 is. Okay, so for example, the other thing you'll notice, back up a second here, the other thing you'll notice is that one of your temperature probes has a piece of tape around it. So that's so that we can tell them apart. So we want to identify if temperature 1 is the taped probe or the untaped probe. So the way to do that is hit the collect button, and then you're going to see a couple of lines start to appear. And this is showing the temperature of the probes as time passes. And if you hold your hand over the tip of one of those probes, it should start to go up because your body temperature is warming it, okay? So in this case, if temperature 1 went up, and that was the taped probe, then I would note that temperature 1 is going to be the taped probe. And that's going to be the case throughout the lab. That should not switch. The colors might change, but temperature 1 is always going to go with the taped probe. If it's the untaped probe, then just make note of that. We don't have to change the tape around or anything like that. We just need to keep track of which probe is which. Okay, for step 3, we're going to set our probes up, and you should have a piece of evaporation paper there. It's just a very tiny piece of paper, and we're going to wrap it around the tip of the probe right like that, and we want the end of it just to be flush with the tip of the probe. And then we're going to take the evaporation paper and we're going to put a rubber band around it, a little orthodontic rubber band, and you should be able to get 2 or even 3 wraps. We want it to be nice and secure on there. So that is our basic setup. You might want to make a quick sketch of that in your booklet. So moving on to step 4, we're going to have our 6 liquids in 6 different test tubes, and 2 at a time, let's call these liquids 1 and liquid 2, we're going to put our temperature probes into those liquids, and we want to be really careful here not to tip the test tubes over. Okay? So step 4 says at the same time, put each of the 2 probes into different liquids, confirm the identity of the liquids so that you don't get the probes mixed up. And then we're going to press the collect button on your software on the computer. Okay, then moving on to step 5, it says to leave each probe in the liquid until you see a flat line on the graph. And this is anywhere between 10 and 10 seconds and a minute, okay? And I'll show you what the graph should look like here in a moment. Once you have a flat line, click on it to see the starting temperature. Record this temperature in data table 2. So this shows sort of the whole line. This is what it's going to look like when you're all done. Notice at the start here that I had a good flat line before I moved on to the next step, okay? So step 5 says to leave each probe in the liquid. Okay, I already read that one. Step 6, remove the probes from the liquid simultaneously. So we want to do this at the same time. You should have 3 or 4 people in your group so we can cooperate. And continue to collect data. So as soon as I remove the probes from the liquid, I should see the temperature start to drop for both lines. That's because there's liquid on the tip of the probes and it is evaporating and it's doing its job. It's carrying heat away from the temperature probe. Okay, the 2 lines are going to look different because they're different liquids and they have different IMAFs. That's kind of the main point of our lab here. Step 7. And we should be recording all our data in this table right here, okay? So this is your starting temperature. That's where we had the flat line. You're going to want to record that for these first 2 liquids. So step 7 says, after removing the probes from the liquid, the temperature should drop. Continue to collect data until the temperature starts to climb again for both liquids. Note that the temperature will start to climb more quickly for some liquids than others, again, because they have different IMAFs. So we see here that both lines have bottomed out. The blue one bottomed out right there, and the red line bottomed out somewhere in there. Okay, so that's going to be our lowest temperature, and we will record that on table 2. But what we're really interested in is this change in temperature, or delta T, which we see over here, and that's the difference between the highest temperature and the lowest temperature. So one thing to note with step 7, as it says there, it says if the program stops collecting data, then follow these instructions. So what I mean by that is, let's look up here at what I've got on the screen. So both my blue line has bottomed out right here. So as soon as the temperature starts to climb again, the liquid has already evaporated, so there's no more evaporation happening. But if I look at my red line, you see that it's still dropping. And if my program stops, then I need to note my starting temperature, because all this data is going to disappear, and I'm just going to hit collect again, and I'm going to continue to monitor it until it finally bottoms out. Some of these liquids are going to take longer than 180 seconds. So as it says there, record the starting temperature for each line in data table 2, and then press collect again and continue collecting data for the line or lines that were still dropping. Okay, step 8 says after stopping data collection, record the starting temperature from the flat line and the lowest temperature for each of the 2 liquids in data table 2. Finally, step 9, we're going to throw away the evaporation paper, replace it with a fresh piece, and repeat the above steps for the other 4 liquids. So this here shows what I'm talking about. We already did these 2 at the beginning, but we're going to repeat it for these 4 liquids. Okay, we're going to always do it 2 at a time to expedite it. So really you're running 3 trials each time we do 2 test tubes. Before we conclude here, I just want to remind you the biggest temperature change equals the most evaporation equals the weakest I mass. And to relate this to something we've been talking about in class, that would also go with the lowest boiling point. So that's kind of the main idea to consider as we wrap up. Finally, some reminders for today's lab. Put everything back exactly as it was. Carefully read the instructions on page 40, that should be. Take thorough notes on pages 41 and 42, that should be. And we've gone over all the rest of this stuff. So just remember your basic lab etiquette. Thank you for listening. Have a great lab and a great day.